Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 4 from lesson 6-4 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to interpret the inverse of a formula involving logarithms. Now, I need to go ahead and be very specific about this. We aren't finding a true inverse, right? Because normally when I find an inverse, I replace the variables, I swap them. Now understand, in this case, I'm not going to be swapping them. I'm going to be leaving the variables where they are and just solving for a to get a alone. So I'm finding an inverse in that I'm finding a different variable, but it's not like a mathematical inverse like you think, because a and r have very specific meanings. R meaning revenue and a meaning cost in this case. So I can't just swap them around nilly-willy. Okay, so here we go. So a company's using this function to show their sales revenue and their advertising costs. And so they want us to find the equation of the inverse of the formula. So essentially they want us to solve for a here. So my first thing I'm going to do is I'm actually going to subtract 25 from each side. And then I'll write it down the next part. I realized I didn't leave myself enough room. So when I'm doing this, I need to first get this logarithm alone. So that's why I'm getting rid of the 25, because in order to break a out of the logarithm, I'm going to need to exponentiate, okay? And when you exponentiate, the log has to be alone. So now I'm dividing by 12. So I have r minus 25 over 12 is equal to the log of a plus 1. So now this is a common log, which means that it's log base 10. So when I exponentiate, I'm raising 10 to that exponent on each side. All right, so I have 10 to the r minus 25 over 12 equals a minus 1, and then I'm going to add 1 to each side. So in the end, my equation is a equals 10 to the r minus 25 over 12 plus 1. So what's happening here is as the r is increasing, this exponent is increasing. So therefore the value on this left hand side is becoming larger. And on this right hand side is becoming larger. So because a is equal to that, a is also increasing. So as the revenue increases, the ad money increases. As the ad money increases, the revenue increases. So to figure out a optimal budget, I would probably want to pick a value for my revenue that I'm trying to go for and use that to help me figure out a. So for that particular use, this equation, the one that we just figured out, might be easier than the top one. Now, the top one would be useful if I know how much I have for advertising to help me estimate how much revenue I could expect. So they're both useful, it just depends on what piece of information you have. So there you have it, guys. That is looking at a model using logarithms. Until next time.